So next we've got our Professor Peter Ralph. So Peter is an internationally respected academic and research leader in the fields of algae biosystems and biotechnology, seagrasses, and the adaptation of aquatic plants to warming and acidifying oceans. He's also a professor of marine biology at UTS, and executive director for the climate change cluster in the Faculty of Science. He's also led the National Multi-Institutional Commonwealth Scientific and Industrial Research Organisation, Marine and Coastal Carbon Biogeochemistry Cluster, and was Deputy Chair of the Sydney Institute of Marine Sciences. He's also founder of the New South Wales Deep Green BioTech Hub. I've been part of that hub and it's really cool. As a member of the Intergovernmental Oceanographic Commission, Blue Carbon International Scientific Working Group of UNESCO, and an advisory panel member for the Czech Academy of Sciences Global Change Research Centre. So he wants to establish functioning examples in the circular bioeconomy using algae, such as bioplastics, alternate protein sources for food, and feed and wastewater remediation. So we welcome Peter Ralph, who will be talking about the Australian circular blue bioeconomy. Thanks, Peter.
Thanks, Adele. Let me just get my screen on. How's that working for you guys?
Don't see it yet.
No. Okay. How about that one?
Nope. Oh yeah, here we go. Hang on. Yep. Yeah.
Success.
Yeah.
You gotta love it when technology works. First of all, I would like to add to Adele and Tessa's acknowledgement of where they're from. So I'm from Gadigal country, and yeah, it's important to have those respects up front. So yeah, thank you for the opportunity to talk to you all today. I'm really excited. Going after Colin is a good opportunity because I can cut out one or two of my slides. So that'll give me a bit of extra speed. So that'll come in handy. What I want to do tonight, for those in the Eastern Seaboard, I want to give a quick run through of who we are from UTS. I'm going to take a slightly different approach from where Colin went. I'm going to focus more on industry and where I think the opportunities are, but I'm still going to run through a bit of the tech and a bit of the green economy, the green chemistry angles. I will absolutely focus on algae only, but I think a lot of the examples that I give, they're plant-based biotechnology. So it's how can we use novel chemistry to make circular opportunities, but it's important that we link this back to industry and understand how we're going to transform things. So that's essentially what I'm going to cover through in the next 15, 20 minutes. As Colin started with SDGs, I'm going to start with planetary boundaries. And for me, the scary process is in the last 14 years, we've exceeded an additional 6 to 7 planetary boundaries. And I think these are the things that are wake-up calls for us, that we need to understand what is society doing and what do we need to start not doing. And chemistry is a critical part of how we're going to adjust our society to ensure that we do stay within the planetary boundaries. And the same as Colin, I'm an optimist. I can see opportunities, and it's you guys that are going to be part of the solution that I think is really important. And I think the older people that have been banging on for this for a fair while, I think what we can do is guide where the effort needs to be addressed. I think there's a lot of opportunities out there, but I think certainly for me and my institute, I'm focusing on where our greatest return on investment can be, as in intellectual return, because where we try and do these solutions is really important. So I head up a research institute at UTS. It's called the Climate Change Cluster. We're about 100 staff and students. I'm also the director of the Deep Green BioTech Hub, which Adele mentioned, and I'll flag some of the research that we're doing through that. The important thing that we're addressing is how do we inform industry about creating sustainable economies, and the bioeconomy especially. And so that's where our focus is. We have 4 distinct teams within the institute. We've got an ocean microbial group, we've got a coastal productivity group, a future reefs group, and an algal biotech group, and that's the group that I'll talk about this evening. The Deep Green Biotech Hub is an incubator that is funded by the state government that's outside of the institute, but we mentor people and we bring companies and startups into the university through the Deep Green Biotech Hub. Technology that I'll be talking about, as I said, is algal-based, and we're actively working across a range of different chemistries to solve these problems. And the industries we work with, I'll share a few of those with you. The important thing for where I think we need to start with the green chemistry is the products that we're making and the industries that we're working with at the moment just won't cut it into the future. Business as usual with manufacturing needs to change. How it's going to change, it's up to us to find the solutions. But essentially, we've operated, the past generations have operated where environmental damage is an externality. That means it's somebody else's problem. It's not business's problem. We've also used brute force chemistry, where we just simply use high energy, high electricity, high pressure, high temperature. We get what we want, we extract it from the product, and we don't worry about the waste. And that's exactly where the green chemistry comes into solving how we're going to fix the planet for the future. So in some ways, I see it that the greatest challenge is fixing the planet, but for us in the green chemistry and the circular economy, it's our greatest opportunity. So that's why I think we need to be engaged with it. So where does the bioeconomy fit in? The bioeconomy is going to be our future economy. The past economy needs to be fixed, and biomanufacturing is going to be the way that we move forward. So we're going to be using less carbon in all of our products. Essentially, we need to understand what the carbon is in all of our consumer products, and then we have to work out whether it's energy that's causing the problem or it's the raw materials that are causing the problem. And I'll talk more about a technology and an industry group in Europe that's working out how to tease apart that problem. We've got to find ways of, as Colin mentioned, replacing fossil-derived components in our everyday commodities that we use. Most of that for our work is also in the bioplastics, but we cover a whole range of different opportunities. Understanding where the feedstocks, what we've got to be able to do is work with industry to understand how not to need new instruments and new equipment, but to essentially pull out one feedstock, put in a new feedstock, and for it to work. Generally, that doesn't happen, and a lot of our work that we've done in China, when we put a new bioplastic into an existing system, it burns, it sticks, something goes wrong. So there's a lot of scaling up, and the work that you do at the lab bench doesn't always work at an industrial scale. And this is one of the challenges, I think, for universities and future researchers coming through universities, is working out where to fit in this intellectual challenge between the bench and industry. I'll touch on the issue of reducing our environmental footprint. I'm focused mostly on the carbon footprint, but essentially if we can start reducing the amount of waste that we're putting out, then the planet's going to be able to sustain the economies that we have going forward in the future. So it's heat, CO2, water, and contamination. It's not just CO2 is the problem. Following megatrends is kind of something important because that tells us where industry and money is going. And the World Economic Forum put out its 10 top topics of where investment's going. And it's interesting that green technology for carbon removal was stated as one of the top techs for this year. That includes yeast fermentation and on all of the bioprocessing, but also it includes algal-based production. And this is a massive industry, and this is where I think you guys for future jobs should be looking carefully at where you can fit into it. Now, as this is a global presentation, I'm very proud of Australia's 5th position in our, this is the World Economic Forum's assessment of where the money's going in the green tech linked with carbon removal and those 3 sets of organisms, yeast, bacteria, and algae. So Australia's sitting fifth as far as company investment. We're not even on the map as far as government investment. So if there's any politicians listening, Australia needs to get its game up. But the areas are predominantly services, waste remediation. That's where the money's going. So what we do is we work with algae to capture the carbon, use waste, and then move it into products. And it's exactly the same as what Colin was describing. Types of products that we can work with is proteins we can make into pigments, we can extract oils. Exactly what Colin mentioned, we just do it exclusively with algae. The important thing that we have to do, though, is we have to find the producer, the manufacturer, and the end market. Because these aren't existing at the moment, we've got to put all three of the supply chain together. That's sometimes quite difficult. But as I said before, it's getting from the bench to the industry that as chemists, you need to work with us carefully to do. Now, I only put a little bit of green chemistry up to start with. I want to move a lot more towards the circular economy, but these are some of the technologies that we're working with industry partners to develop. So we work across the deputatic solvents, the ionic liquids, supercritical CO2. We've worked with Colin in the past in this area. We're doing a lot of work in biomining and bioextraction, waste valorization, and this, as Colin mentioned, is the biorefinery approach. And also coming up with low carbon equivalents and how to get those into the systems. And so this is fibers, plastics, the same kind of technology. Where the Deep Green Biotech Hub comes in is one of our early partners was a brewery called Young Henry's, which is an inner city Sydney-based brewery. They wanted us to capture their carbon, and so we developed the technology to do that. But that was 3 years ago, and we've moved beyond that. And they wanted to create a more circular system where we use their waste. One of their waste streams is brewer's spent grain. And so we capture the carbon, we blended it with their brewer's spent grain, and we fed it to the cows. And this isn't the Asparagopsis story that Colin mentioned. This is another algae that is being used to circularize, use two waste streams, improve the condition of the cattle, and reduce the methane emissions. So this is where circular economy really starts becoming economically viable. Now, I was going to show you this rolling schematic out of LinkedIn, but the biomaterials that are being produced is absolutely phenomenal. The types of raw material that's going in is very exciting. Mycelium, seaweeds, alternate wood. I was just in Europe, and we need to get the lumber industry to start seeing timber as biomaterials, not just lumps of timber to build houses with. There's 300 startups in that scrolling. If you download that link, you'll see there's a lot of money moving into this space. Now, I didn't realise that Colin was part of Samara Eco, so I won't go into any of that, but I will talk about Ulu. So Ulu is one of the recent startups in Australia, and Ulu's making plastics out of seaweed. And this is a really exciting group, young group of entrepreneurs. They've just secured some more funding from Main Sequence Ventures, which has also supported Samsara Eco. And this is where they take the seaweed, they take the sugars out of it, they use a bacteria to create the PHA plastic. So this is one of the circular opportunities, I think. Now, where I see the opportunities for the chemists is not just to look where the current industries are, but work out where the future industries are. Now, this is going to be an interesting challenge because once there's carbon prices or carbon border adjustment mechanism, which is what's happening in Europe, we're going to have to work out where our products are being exported. If they've got high carbon content, they're going to have a tariff. So there's going to be opportunities to find out how to embed lower carbon content into everyday products. And so there's a system in Europe called Astanium, which creates a blockchain. And the blockchain describes the carbon footprint, product carbon footprint. And if you have a lower carbon footprint, you're going to have a lower tariff. So the industries that are going to be impacted is going to be massive. So this is where I'm suggesting we need to be thinking about not the big players, and we also need to be thinking about which the companies and where they're going to pivot to. Lamborghini used to be a tractor factory, a tractor producer. Samsung was a grocer. LG was a facial cream manufacturer, IKEA was a pen importer, and DSM was a coal miner. So what are these companies going to be in the future when they move into the bioeconomy from the old economy? The acquisitions and mergers are going to be phenomenal. So this is going to be an exciting space for chemists. So reflecting on where I think the opportunities are, these are some of the technologies and some of the industries that you guys need to be targeting and understanding how you can disrupt these manufacturing supply chains. Industrial chemicals, obviously. Domestic chemicals. We're going to need a lot of these boring chemicals off fossil-derived components and onto biogenic based. Pharmaceutical, and Colin mentioned this, the bioplastics is massive, whether it's packaging, cabling, all of these things are really important. Colin mentioned SAF, that's important, textiles, construction industry. So that's where the opportunities I think are. And so I hope I've given you an overview of where we're going through both C3 and the Deep Green Biotech Hub, where I think the opportunities for the employment and where I think the capacity of green chemistry is going to be really needed to link up where the market and the products are. So I hope that gives you some food for thought, and I look forward to finding out where the questions go afterwards. So thanks for your time.